here we've got a panel discussion, and I want to just sort of preface it to say that Cheryl Stubb-French, who was slated to moderate this session, was unfortunately called away on a family emergency. So we're really sorry to not have her here today. She's the professor of, well, many things at UBC, but I think what most of the local folks will know her for is her work in building information modeling, integrated project delivery, and modern methods of construction at the Civil Engineering Department at UBC. So I regret to inform everybody that you've got me moderating the session today. So this is going to be focusing on discussing the education aspects. You heard the minister this morning talking about how we build capacity, how we get the knowledge from the research centers, from the labs, from the innovators out into the marketplace, and how do we build that workforce of tomorrow. So I want to welcome our panelists up here. We have Annalisa Meyboom, who is an associate professor at the School of Architecture and Landscape Architecture at the University of BC. UBC, come on up, Annalisa, nice to see you. So her area of expertise is in the integrated design of engineering and architecture, and her areas of research include advanced design technologies and robotics in wood design and fabrication, as well as future technologies in infrastructure. Next up, we've got Carla Dickof, who is an associate of Fast and Ep structural engineers, pioneers in all sorts of innovative structural wonders, but obviously foremost in the world of advancing mass timber. Those of you who saw the concept lab yesterday on the tour would have seen Carla in her native environment, I hope. So Carla really leads the work of a whole range of research projects, including multi-shear wall testing for schools, composite mass timber systems, timber brace framing testing. Goodness, it goes on and on. Carla's got just a wealth of interesting and wonderful projects. And then finally, Dr. Dorian Tung from FPInnovations. Dorian, where are you? Oh, there you are. So Dorian's a professional engineer and currently the Vancouver manager of building systems of Sustainable Construction Innovation Centres of Excellence in FPInnovations. So for those of you who don't know what FPInnovations does, they are Canada's premier timber R&D organization. So they sort of fit between the academic work that Annalisa represents and the industry innovation that Carla is part of. So he's dealt with intellectual properties, knowledge transfer, and research dissemination in addition to delivering research and development. He's been responsible for contracting, sales, and marketing, as well as maintaining business relationships. So welcome, you guys. Thank you very much for joining us. So the way we're going to do this is each of them are going to come up and just share a few thoughts, a couple of slides, just to kind of give you a flavor of what they do. And what they're sort of working on to sort of advance the world of mass timber and timber technology broadly. And then we'll get into a discussion. So please think about some questions. We'll allow some time briefly at the end of the session to maybe engage you guys. But I think, Annalisa, you're going to be up first.
Thank you so much. Hi, everyone. It's a pleasure to be here and see a lot of friendly faces in the audience. Today I'm just going to talk about what actually I do at the university and how I teach some of these things. So I'm an associate professor. I'm in the School of Architecture and Landscape Architecture. I mainly teach graduate architects, people who are doing their MArch, and I teach. My background is in structural engineering, and then I did architecture after that. So I do a lot of kind of integrated design. My area of research and teaching mainly focuses on advanced parametric design, structure and form, digital and robotic fabrication, and implications of fabrication constraints on design. So those are the things I'm trying to kind of, work with the students on learning. And I'm gonna show you a little bit of a video that some of you might find parts of familiar if you look at where the things are sourced or who's talking, just to give you kind of an overview of why it's important.
from the manufacturing of computer chips to the way we make cars. Robots aren't the whole story. How data is created, collected, and interpreted has fundamentally changed the way we live. And now, those same changes are happening in construction.
As we want to build more precise buildings that function better, that work better, that meet energy codes, we've got to build at a precision level that's hard to do with a skill saw and a nail gun on a site when it's raining.
Using robotics, it allows us to assemble more pieces and more complex pieces that in totality result in higher performing building components.
Architects and engineers now have access to powerful parametric software that can create and analyze complex geometries.
When parametrics give you great control of the geometry, the next challenge is moving it into construction, because you need the accuracy in construction to be the same as the accuracy in the geometry that you have when you design.
At the Center for Advanced Wood Processing in Vancouver, researchers from the University of British Columbia and the University of Waterloo are working with Intelligent City, a local leader in mass timber construction, to make robotic fabrication more accessible.
There's a difference between what can be designed on paper or in software and what can actually be manufactured.
We're looking at very free-form geometries, very curvy and expressive geometries, but it's very much the same as if we were to be designing a house. Now, what's really cool about this computational process is that we can manipulate, and if I change that house and not 8 by 10 meters, all of those elements are also correlated to that, so they will adjust. So if my door needs to be in the center and I change the length, that door will move and align itself with the center of that house. Normally, this is something that we do in design, it's called associative design or parametric design. But here, we're also connecting that to the manufacturer. So we can take that wall digitally and put it flat in a way that then can be manufactured.
Robotic fabrication is not only meant to automate existing processes, but to augment what we can do and further to introduce new processes that were not possible previously.
So that summarizes in a really succinct way what we're trying to do and how we're working with some of you guys to do that. I'm just going to show you a few of the examples of kind of what happens in the processes and what we're doing. So this was our latest workshop here, which is basically looking at how do you get from when we get to the advanced parametric designs, that have very high accuracy, how do we get those out into the fabrication process? So this is our latest one here. So we're just kind of doing a test project that really kind of tests the limits of what the precision of the fabrication is, what it means to have the instructions for assembly within the elements themselves, and then how do you go about, like, what's the accuracy and the difficulties that you come to, on a very small scale when you come to the site. So that was the one from this year, and then we've done this for several years. There was obviously a COVID break, but and this was one from 2019. So again, double curved wood. The reason for that is just because it's very difficult. There's a lot of gradients as well. We try to make things even more difficult by doing that. This one has obviously, you can see it's many things that are being adjusted at that time. Even here we use a little bit of kerfing. You have wood-to-wood connections in most of them, so we're not using steel as much as possible. And the things that the students are learning are understanding machining, robot code, G-code, tolerances, precision, instructions for assembly integrated into the design, structural forces and connections, and implications of parametric design and precision, which of course is a very tall order. The idea is that we do this, and then when they go out in the world and they can then apply these in how they design in future. This is a design build project that we did for a chamber music group. Again, this one actually had steel fabrication, and we used our, you can see we used our robotics, again with the Center of Advanced Food Processing, to try and get that kind of double curved surface. In this case, it was for acoustics, so there's a lot of acoustic parametric modeling that went on for this, which actually amazingly worked quite well in practice. Always, always a challenge. And then this is the back of it, which has a really nice kind of mahogany finish on it. This summer, I was teaching the students a performative wood seminar. Again, we used our robot, and they had to then design the things themselves, including very complicated finger joints, more wood-to-wood connections, and that type of thing. So basically, that's what we're doing in the School of Architecture. Thank you.
It is me. So I'm a little lower tech. I don't have a fancy video for you guys. I'm just going to talk a little bit about what we do at FastNep. So FastNep is a structural. We're a structural engineering company that have been around since 1985, and we're really steeped in projects and delivering beautiful buildings or practical buildings or really whatever the client wants. We do have a long history of doing mass timber. We were doing sort of NLT stuff well over a decade ago, maybe a few decades ago at this point. And then as CLT has come on the market, as GLT has been made available, MPP, all of those things, we really have adopted those into our vernacular. And one of the things that we're always looking for are ways we can do more for our projects. It really is focused on that project. So whether ways we can make it cheaper or easier to build or achieve some architectural desire or any of those things. And sometimes, particularly in the world of mass timber, because it is so much newer than traditional concrete construction or traditional steel construction, because it's so much newer, we sort of find ourselves up against unknowns more often. And that's sort of where our history of getting our hands into the research side of things has come in. And so what I'm going to do is I'm going to talk about some of the stuff we've been doing in recent years that are really in response to things we've been needing on projects or wanting on projects, and sort of to give you an eye on where mass timber could be going. So one example of this, there are two mass timber elementary schools in Vancouver. They're Vancouver School Board schools. They're both fully mass timber. So mass timber, CLT shear walls, CLT floors, CLT roofs, pretty much everything, all the ceilings exposed, except maybe in hallways. Shear walls typically exposed on at least one side. They really wanted to utilize that mass timber. And one of the things we were facing is the limitations on CLT shear walls that are in the code. We wanted to really push beyond those, particularly because they add a lot of complexity on fabrication and installation. You just end up with a lot of connections with the ways things are set up in the code, so we wanted to see how we could push beyond that. And our approach was basically to look at multi-story continuous shear walls. So instead of having, your shear wall, your big CLT panel cut up into little pieces to build up a shear wall again on each separate floor, having a single panel span over multiple floors with the intention of hopefully achieving the same performance, same earthquake resistance, all of that stuff, but reducing the number of connections you need significantly. So this was something that fell outside the code, and we were lucky enough to get a grant from NRCan through the Green Construction and Wood program. So we partnered with UNBC to develop and then execute a testing program where we could sort of identify the unknowns associated with this kind of system and then satisfy ourselves that this basically achieved the same resistance, at least in this building. So this is, not ready necessarily for full code implementation. I hope that it's a step towards that. But this in this project, between the modeling and the testing and the analysis that we did on our building specifically, we reached a point where we were able to implement this type of shear wall with a high level of assurance that we would get the performance that we needed from it. Another example is Limberlost Place in Toronto. This is a university building for George Brown College. It's 10 stories of mass timber. And because it's a university building, they want really open spaces for classrooms, for atriums, all of that stuff. It was a competition-based building, so it won a big architectural competition. And the approach here was to use a sort of slab band system, but in CLT. So we had very thick composite, concrete and timber composite slab band systems with thinner CLT panels spanning between them to create, I believe it was 9 meters in one direction and 11 meters in the other direction. So very, very big open spaces with no significant drop beams, not quite a flat slab, but a very open system that wasn't going to have mechanical issues. You weren't worrying about how you were going to bend ducting around beams or anything, or pass through beams or anything like that. So this, we wanted to create a system that would achieve that composite behavior between the concrete and the wood efficiently. We wanted to, traditional is maybe the wrong word, but the systems that have been implemented in the past tend to come at a high cost in material, whether that's screws or plates and glue, very labor intensive for installation. So we wanted to see if we could do better. Similar to the last project, this project was also lucky enough to receive a pretty significant grant through the Green Construction and Wood program from NRCan. So we were able to partner with UNBC again and execute a really big testing program. I think it was upwards of maybe 500K even. Full-scale testing, small-scale testing. And basically where we ended up was a system which used just plates that were just basically hammered into the wood. Slight kerf fabricated in shop and then hammered into the wood. And these plates avoided the glue that's often necessary in the plate systems, avoided the time associated with huge numbers of screw installations, while achieving sort of what we needed for this program. And I think it saved the project at least $1 million. I'd have to look into the exact numbers. It might have been more than that. So this is another example where we needed to do this testing to get the project where we wanted it to go, and it really allowed us to push things further, to get that really open floor span. Another example is the BCIT student residences, and this is sort of the next generation. Many of you have probably heard of UBC Tall Wood at UBC, which is the first 18-story mass timber building, I think, in the world at the time. And that building uses panels supported on columns, no drop beams. So that's sort of the opposite, much tighter spaced columns, but no drop beams, so you're avoiding mechanical issues, and is also very cost efficient. This is a new building that we're designing right now, which is pushing that further. It's using bigger panels that are now on the market. It's using smaller columns in the form of steel columns so that those columns can get buried in architectural partition walls. And it's really, we wanted to take the research that we did in partnership with FPInnovations actually, to the next level. So right now we're undertaking a large testing program to better define what the behavior of these two-way panels when you actually engage them in two-way action, when you avoid those beams and all the complexities that they bring from a mechanical, electrical, from floor depths, and all that stuff. So this is these are images from the testing that was done as part of the UBC Tall Wood project. So we're going to be doing a larger suite of testing for this to better understand the behavior of these panels overall. We'll be doing small-scale tests and large-scale tests with the hope of eventually informing the codes so that people that want to do this type of design in the future won't have to go through these rigorous testing programs. And that's just basically a small sampling of the work that we've been doing on the R&D side to serve our own needs for projects. And we really do keep, even though as we venture more and more into the world of research and R&D, we really have a strong focus on just what do our projects need today or tomorrow. We're in the industry, we're living it. So we're not necessarily always going to be the blue sky thinkers, the ones who are taking, you to 2050. We're more looking to like 2025, if that makes sense.
Okay, let's see if it works. So as Helen has said, we positioned ourselves as the in-between university and the industry. We see ourselves as a marketing enabler and market accelerators doing applied research specific for maintaining and expanding the market for the Canadian wood forestry forest sectors. We have offices across the countries. We're headquartered in Quebec. We have a large presence in Vancouver, and then we got offices, like I said, across the countries. I'm from Vancouver, and our laboratory, both here and Quebec, we're ISO accredited under 17025, both routine tests and non-routine tests. What that means is we perform tests. Our data could help the industry to get their product into the marketplace at an earlier stage if you're an early adapter to get through the authority having jurisdictions. So that's a bit about the companies. A few years ago, actually 4 years ago, Helen worked with us, and then we start on the journey of industrialized constructions. I'm sorry, the slides is advancing differently than that. So we see the industry is changing as robots work its way into the construction sectors, as computers start to become a part of the workflow. So we want to make sure wood remain as the preferred construction material as the industry changes. So we're currently on our year 4 of the program, and we are looking at the entire value chain and what we need to do, what the wood industry has to do in order to be ready when it comes. And so we look at the lumbers, how our lumber is different than the lumber, say, in the European market, and which is very advanced in terms of automations and robotizations. So we look at what kind of technology, what kind of the best practice that can be done to make our lumber more suitable for robots. We also look at the EWP, engineered wood products, how can we cost it down, which is already naturally straighter for the machine, but the cost is fluctuating. So what can we do to cost things down? And we also look at typical simple practice of face gluing, finger jointing, and then look at how that's not widely adapted here in Canada for to be better suited for machine. Then we also look at what's available in the marketplace in terms of its software, hardware, and what are the gaps, what needs to be filled. Not necessarily filled by FPInnovations, but what we could do and partner with the university and with the industry to create those gaps. So then when the parts are here, and then we have the entire workflow to accelerate the process. And we also look at the components of the building panel, building modules, and that's where some of the texts are in white, so it's not showing up here. Or in black, I guess it's not showing up here. And we also look at the building systems as a whole, looking at structural behavior, fire behavior, and building envelope performance. So in a holistic approach to make sure the final product is still in the highest standards. And not only we look at the design, the constructions, the product, we also look at post-occupancy. See how the building performs, the mass timber building performs using technologies. So using the latest out on market on sensor technology, IoT technology, we want to instrument those buildings and get data and provide that feedback to the broader audience of what the building, how the building really performs. So we partner at, this program I'm showing here is funded by FII. So we have a program, we want to be able to get the data for the latest building that's coming onto the marketplace, get the data, and then we could then start to go into those data to do analysis and then to see how the different component systems behave differently. So not every building will get tested and then go into very great details. We understand that. So to really accelerate the process to get more and more people being able to handle mass timbers, we did a survey years ago, and we understand having some guidance on how to model that in your office is very important. So this is a guide that we recently published, and it was 2 years in the making. It's now available on our website, free to download. It's a great guide, first of its kind. It's collaboration of more than a dozen countries around the world, more than 100 collaborators. It has a lot of practical information that allow us in the industry to go and model and get the performance of the building in preparation for performance-based design. So I encourage you to download this guide and ask questions. So as we're moving into this new era, we're asking the questions. How can we develop the supply chain to be sustainable and to be able to do it offsite, able to do it in a controlled environment to still provide the most highest standard product. So it's really encouraging to see what the industry is pushing and what the university is doing in terms of adapting its curriculums. And last week I was having the pleasure to go on the tour hosted by the Center of Advanced Processing. It was really good education for me to see how the future is here and how the work that we're all doing is making a difference. And we just have to really think about technology, put that in the center of our thinking as we're answering those questions. And by no means the picture I'm showing here is exhaustive. It's every software and hardware company. I apologize if I missed your company. It's just trying to make a point that technologies are here, there are gaps. And as an industry, as a designer, know what the capacity of software and hardware will really help to make profit out of the existing technologies. As a software developer, hardware developers, if you are able to connect the dots, fill the gaps, then I think we can all move together. Thank you.
Hello, is this working? No. Hello? All right, I'm going to go up here then. Dorian, is yours working too? Can you just make sure? Good. Thank you very much, you guys. Super interesting, different perspectives from the sort of R&D spectrum, from education through to the research. What I would say, it sounds like you guys have been very successfully super busy. There must be things standing in your way. Construction is not the industry you would consider as being the most sort of R&D forward. Annalisa, where are the barriers? Like, what's stepping in your way? What would you need to do more of what you do, and where do you think the gaps are?
Well, I think the industry in general is very fragmented, and each consultant or each part of the industry, each fabricator, each contractor, needs to take care of their own, their own concerns, and that the problem is that it's a very litigious industry. It's a very an industry where people are not working together, they're working kind of to forward their own interests. That means that they don't want to do any extra work that isn't required in their contract because everything is done low bid. And this is, therefore nothing is integrated, and nobody has any interest in integrating anything because it doesn't do them any good, and they're being pressured at the same time. So this kind of lack of kind of integration in the industry is highly problematic. And so even if you have some ideas that you'd like to take forward, the whole thing is set up structurally so that it's not in anyone's interest to do that. There's a lot of innovative companies in BC that would like to do that. But again, whenever you kind of tender a project traditionally with the way that you kind of set up the contract, that it doesn't allow for innovation, and then we have to figure that out.
Dorian, you had some really interesting points around, kind of, the roadmap that FPInnovations is on, and, sort of the evolving role that your organization has in sort of, bringing it all together. What would you say has been sort of the key enablers for you? Like, what's opened the doors to FPInnovations' sort of new view on its role in supporting the construction industry? Because historically, you've worked with forestry companies. Am I correct?
Yeah. So, a bit also linked to your previous question, Helen. It's we're finding most of people don't want to be the first one, and they have a great idea. There's a lot of documentation, evidence out there. There's a market, but people are, understandably don't want to be the first one. And then in the past 2 years, because of COVID, that become even more obvious. So. What we're finding in the journey is if they see the access to research and access to some of the stuff that's available, they get a bit more confidence to be the first one to be able to go in there and test out the market and to be the early adapters. So a bit hand-holdings from people that has done this, I think will help. And what we heard earlier from the minister, I think was great, that the government is driving that as a requirement. So I think that will make a change in the near future.
Thank you. I'm glad you brought up what the minister was mentioning this morning, because I think most of us noticed that in his job description was jobs and employment. Carla, yes, you are a researcher and you're working, but you're also working for a business that is at the forefront of construction. What are your thoughts around sort of how you bring people into your company with these expertise that you're looking for? And, what can, for example, Annalisa do to maybe prime her students to be of the, most relevant, with the most relevant skills for your company?
Yeah, that's a good question, and we do sometimes struggles maybe a bit overdramatic, but when we bring people on, there is even a very experienced engineer who's very talented, really knows their stuff with traditional construction, may have never done any design in mass timber, or maybe they put up a post and beam your roof somewhere or something. So we find that we look, when we're trying to hire, we look for people who are good at thinking, who are good at understanding just basic building behavior, and then we do have a bit of an internal expectation that we're kind of going to be training them in timber on the job. So it would, and that has started to change. We do see new grads that we hire coming in with some work from their classes where they've done some mass timber stuff. Different universities have different extents of that. So that is very promising. And I think it's just going to be time. I think really pushing in the academic institutions to get engineers getting more classes where they're dealing with it, and architects getting more familiarity with it, because there are many great architects who have experience in this and do understand what mass timber is good at and what mass timber is not good at. But there are plenty of people out there who just sort of pretend it's concrete and then assume you'll figure it out on the back end. So I think just that continued education. And then I also think, guides like the modeling guide from FPInnovations are huge steps forward that really help people that are maybe less familiar have like good, solid documentation as to how to do things. So that's a huge advantage, and I think just more education and honestly more buildings getting built, right? If there's more buildings getting built, then more companies are going to chase it, more people are going to get experience, and it sort of becomes like a snowball rolling down a hill.
I am going to keep asking questions, but I am now going to invite anyone who is interested in also participating in the question asking process to step up to that microphone right there. If you're there, then I will pass the floor to you. Jerry, if you can maybe check in with the online community and see if there's anything pressing that we need to hear from them, that would be great. In the meantime, I wanted to ask about funding for research and education. I look at some of the other industries out there that have got a very well organized sort of R&D resource, either from government or from industry themselves. I mean, maybe, Annalisa, I'll ask you first from the university side of things. What is it like, right now, trying to make construction a serious contender for sort of traditional R&D type funding that universities might normally go for?
I think, the funding is not, the funding that that universities usually apply through come from NSERC or through social sciences, and so they're less interested in things that are applied. I think that's one aspect, and I think architecture, my field in particular, has a very, very difficult time because we don't fit into any of those categories, right? With regard to national, we don't fit into the engineering NSERC category. And we don't really fit into the social science category. So I find it quite difficult to engage people in terms of that kind of level of interest. But I think, yes, we need to think about what's really going to make the impact. Where is that impact going to happen in terms of the research? And oftentimes, I think when you're looking at industry and what industry is interested in, it's short-term goals, and the long-term things that we might look at the university are getting kind of a little bit of a short shift now because so much of the focus is on what industry wants. And so I think we could move a little bit more away from that in the funding streams as well.
Was there a question? Yes.
Hi, it's Enlai again from Smidhammer Larsen. I'm based in Denmark, so I don't 100% know this particular territory in terms of the way the building industry operates, but if it's anything similar to the rest of the construction industry in Australia or Europe, there is an aversion to risk, but not a very clear understanding within the construction industry of the different types of risk and how to deal with those different types of risk, and breaking the term down and qualifying it more properly. And talking to architects here, I get the sense that the bottleneck in the building with timber is not in the supply chain of the material, but in the manufacturers that are able to deliver onto site, the ones that actually do the CLT construction or do the LVL or glulam or any of the other methods of mass timber that you might be dealing with. And so to accelerate the ability of new players in the market, you need the market to be able to take on a new producer in order to release that bottleneck. And of course, government's trying to do what they can by supporting that sector of the market into production. But to me, the real unlocking feature would be to deconstruct the notion of risk and work out how that risk sharing can happen between government and the industry, because there is risk that is usually unlikely and catastrophic, and there is risk which is a bit of a pain in the ass but not very catastrophic. And the mass timber industry has a lot of both kinds, and they should be dealt with differently, so that when the things are a bit of a pain in the ass and not that catastrophic, where there just needs to be more time or investment to back that up, there should be methods of doing that allow first movers to be underwritten in their ability, in their choice of taking on a new manufacturer, for example. Is I would like to just hear what the floor has and maybe open up to the rest of the floor as well.
Is there anybody wanting to respond? I feel like, Dorian, that's sort of heading in your direction.
I'll say something. I'm not sure if that directly responds to the questions. The mass timber is really exciting, as we all agree. That's why we're all here. It's a platform for a lot of technology to show off what the technology can do, and lots of companies that we work with, it's flexing its muscles, and there are opportunities, there are challenges there. We heard about vertical integration. We heard about companies that just want to go and do one thing and then make it as commodities. So that's all related to ultimately where they see the risk is and whether or not they want to take on the risk and whether or not they're ready and whether or not the market is ready. So that goes on everybody's mind and what mass timber will go, commodity or not, and what's my position. So we're kind of in this and then talking to the industry and we don't know. Right? At FPInnovation, we don't have the crystal ball, we don't know, and we cannot drive the market in such a way. What we would recommend is just be ready one way or the other, and then be flexible and be agile, like in every business.
Annalisa, very quickly, and then I think we'll wrap up.
I mean, because sometimes I also work in industry on the architecture side, and the people that I've talked to when we try to do mass timber buildings are generally like averse to the risk. They're not sure what's going to happen. They haven't done it before. They don't know what's going to happen. They're worried about the rain. They're worried about like the construction sequencing and those type of things. So I think it is a huge barrier to just this newness of the industry, and I think that's exactly where I think the help could be, and also in terms of managing this risk of the kind of the download of responsibility, in different places, and sometimes the government can pick that up, so that might also be useful.
Thank you. One final comment, Carla.
Yeah, sorry. I think the other thing that is very true is that we're very lucky here in BC. A large percentage of the municipalities that I've worked in BC are pretty open to, at the very least, a dialogue if you're trying to push boundaries. But any of these mass timber manufacturers, they're manufacturing a very large quantity of material. And they're certainly not looking to just supply mass timber in BC. They want to supply mass timber across North America. And there are a lot of jurisdictions where there's a lot of hesitancy. There's sometimes just firm no. Whether it's on, the fire, the fire chief just hates mass timber, and that's something that comes up in New York, for instance. Good luck getting a mass timber building built in New York City. Or people have a lot of hesitancy about diaphragms, and so and seismic behavior, and so you'll have jurisdictions where, the code officials will make you put like basically a concrete slab on top of your mass timber slab so that the concrete is taking all of the seismic loads. So I think it's tough because obviously, the minister is focused on BC, but I think there's education that needs to happen on a broader basis to make it more attractive for new producers to get into the game, basically.
Great. That's a really great place to stop, and also a shout out to our online community. Oh, we've got
if
very
time,
quick.
If there's time, yeah.
Yeah, very quick.
Yeah, sure. So there was a mention that the connecting the dots in order to enable the industry to move forwards within manufacturing, robotics, etc., etc. So I work for ABB Robotics. We're trying to understand what those dots are so that we can connect the dots to enable the move forward. So what are the real items that really need to be looked at to enable the industry to adopt the new robotic technology, the new software, and move forwards in a way that is not very, it's reasonably immediate rather than 10 or 15 years' time. So what do you think those dots that need to be connected are?
So I would guess that that's a very long answer. But I'm wondering, Annalisa, can you maybe do like a 30 seconds, because we are standing between everyone and their lunch, and maybe go and have a conversation, a follow-up conversation afterwards. Can I encourage you to do that too? Anyway,
yes, for
30
sure.
seconds.
I think people have to see the advantage of what it brings in terms of what what the technology brings to the industry. And I think once people understand what the advantage of the speed of and the kind of especially if you put instructions for assembly within the manufactured elements, you can really increase that speed and accuracy. You can increase the building performance in terms of envelope, in terms of air leakage and those types of things. So it's like, once you know those types of things, then I think people are more engaged. If they don't understand what the benefits are, then they're not going to bother with the investment or trying to understand the system. So I think that would be the key thing.
Beautifully done. Thank you very much. And I do think that you guys need to have a follow-up conversation.